Adhesive bonding in electronics, chemical considerations. Title: Adhesive bonding in electronics, chemical considerations. Introduction. Adhesive bonding has revolutionized the electronics industry by providing an efficient and reliable method for joining various components. Unlike traditional mechanical fastening methods such as screws or rivets, adhesive bonding helps achieve stronger and more uniform connections that are crucial in electronics manufacturing. However, the success of adhesive bonding in electronics heavily relies on understanding the chemical considerations involved. This article explores the chemical aspects that impact adhesive bonding in electronics, from substrate compatibility to surface preparation and curing processes. Substrate compatibility. The first critical chemical consideration in adhesive bonding is substrate compatibility. Electronics involve a wide range of materials with varying chemical compositions, including metals, plastics, ceramics, and composites. Proper adhesion requires a match between the adhesive and the substrates being bonded. Adhesives for electronics must be carefully chosen to ensure compatibility with these diverse materials. Different adhesives exhibit varying degrees of adhesion to different substrates, and it is vital to select an adhesive that forms strong bonds with each component. For instance, an epoxy adhesive may be suitable for bonding metals, while cyanoacrylates are favored for joining plastics. In some cases, primers or surface treatments may be necessary to enhance adhesion by promoting chemical bonding or improving wetting on the surface. Surface preparation. A critical step in achieving successful adhesive bonding in electronics is surface preparation. Improperly prepared surfaces can hinder adhesive performance, resulting in weak or unreliable bonds. Surface contaminants, such as oils, dust, and oxide layers, must be removed to create a clean and receptive surface. Cleaning the surface can involve using solvents, mechanical abrasion, or plasma treatment depending on the nature of the substrate. Additionally, certain substrates may require specific surface treatments, such as acid etching or sandblasting, to enhance adhesive bonding. Surfaces must also be dry and free from moisture, as water can interfere with the adhesive's curing process. Curing process. Another important chemical consideration in adhesive bonding is the curing process. Adhesives have different curing mechanisms, such as heat, UV light, moisture, or chemical reactions. The choice of adhesive and curing method depends on the specific requirements of the electronic component being bonded. Heat curing adhesives, such as epoxy or polyurethane-based adhesives, require controlled heating to reach the desired strength. UV curable adhesives, on the other hand, utilize ultraviolet light to initiate the curing reaction. Moisture curing adhesives use ambient humidity to trigger the curing process. In some cases, two-part adhesives are used, where a resin and hardener are combined to initiate a chemical reaction. It is essential to ensure that the curing process does not negatively affect the electronic components being bonded. Components sensitive to heat or UV radiation must be protected during the curing process to avoid damage or malfunction. This can be achieved through protective coatings or masking materials. Environmental considerations. Adhesive bonding in electronics must also consider the challenges presented by the operating environment. Electronics encounter various environmental conditions such as temperature extremes, humidity, chemicals, and vibrations. The chosen adhesive must be capable of withstanding these conditions. High-temperature adhesives, such as thermally conductive epoxies, are often selected for applications where components are exposed to elevated temperatures. Moisture-resistant and chemical-resistant adhesives play a crucial role in protecting electronic assemblies from moisture and corrosive substances. Vibration-resistant adhesives are necessary to maintain the structural integrity and functionality of bonded components subjected to mechanical or environmental vibrations. In addition to selecting appropriate adhesives, encapsulation and conformal coatings are often employed to provide additional protection against environmental factors. These additional layers shield the electronic assembly from moisture, chemicals, and other external influences that could compromise bond integrity or electrical performance. Quality control and testing. Chemical considerations in adhesive bonding in electronics also extend to quality control and testing processes. It is vital to establish comprehensive testing protocols to ensure the integrity and reliability of the bonded assemblies. Various testing methods are employed to evaluate adhesive bonds, including lap shear tests, peel tests, and accelerated aging tests. These tests assess the strength, durability, and reliability of the adhesive bonding under different conditions, enabling manufacturers to identify potential weaknesses or limitations. Moreover, non-destructive testing techniques such as X-ray inspection can detect hidden bonding defects without damaging the assembly. Adhesive bonding in electronics has been a game changer in the industry, offering a reliable and efficient way to join components together. However, achieving successful adhesive bonding requires careful consideration of various chemical factors. This article will delve into these chemical considerations, ranging from substrate compatibility and surface preparation to curing processes, environmental factors, and quality control and testing. One of the crucial chemical considerations in adhesive bonding is substrate compatibility. Electronics involve a wide array of materials, such as metals, plastics, ceramics, and composites, each with its unique chemical composition. To ensure proper adhesion, it is important to select an adhesive that matches the substrates being bonded. Different adhesives exhibit varying levels of adhesion to different materials, so it is critical to choose the appropriate adhesive for each component. For example, epoxy adhesives are well suited for bonding metals, while cyanoacrylates excel in joining plastics. In some cases, primers or surface treatments may be necessary to enhance adhesion by promoting chemical bonding or improving wetting on the surface. Surface preparation is another pivotal step in achieving successful adhesive bonding in electronics. Inadequate surface preparation can hinder the performance of the adhesive, resulting in weak or unreliable bonds. It is imperative to remove surface contaminants, such as oils, dust, and oxide layers, to create a clean and receptive surface for bonding.